So good day class. So today we're going to have a lecture on thin joint masonry for the first week of our final term. So thin joint masonry allows the depth of the mortar to be reduced from 10 millimeters to just 3 millimeters or less, resulting in faster laying and improved productivity, particularly on long runs of walling. Construction speed can be further increased by some 13.5% using large format concrete blocks, which have a face size equivalent to two traditional concrete blocks. The mortar cures rapidly, achieving full bond within 1 to 2 hours, eliminating the problem of floating, therefore enabling more courses to be laid per day. So what is a thin joint construction? This method of construction is very well established throughout Europe, and with the ever-increasing tightening of building regulations and codes of practice, thin joint mortar construction will assume greater significance in the UK due to numerous benefits offered by this method. So this joint construction utilizes 2 to 3 millimeter thick mortar joints using a quick setting adhesive mortar, enabling faster and easier construction. And this leads to faster weatherproofing of a building and enables follow-on work within the building to proceed sooner than would be the case with alternative construction methods. Mortar mixing consists of nothing more than adding water to the pre-mixed mortar powder. There are no cement mixers required, just an electric stirrer. Applying mortar is made simple, quick, and foolproof with the use of special scoops, which apply the correct thickness of mortar each time, thus minimizing the waste and maintaining consistency and quality throughout the build. Then excellent thermal and acoustic insulation along with superb airtightness. So its applications are for external cavity walls. An inner leaf wall in thin joint achieves higher compressive strength and has an improved U value than an equivalent wall built in conventional mortar. The inner leaf can be built rapidly, weatherproofing the building and allowing internal work to commence. Then external solid walls, a very simple and effective building technique with external insulation which can achieve U values as low as 0.14 uh, WM squared K, so I'm not too sure what's this, with zero thermal bridging, all with two layers and no cavities. No wall tiles required, no condensation risk, totally waterproof construction. Then for acoustic separating or party walls, thin joint construction can be used for separating walls compliant with Part E of the building regulations or using robust detail designs. Then two leaves of AirTech party wall blocks or AirTech 7 blocks can be used to offer simple, effective solutions. Then for internal partition and flanking walls, a very quick and effective technique for building strong, durable internal walls, including flanking walls to party walls. This quick and clean build method, coupled with low weight, workable airtight blocks, offer a perfect solution to refurbishment and modifications. So these are the benefits of thin joint. So thin joint construction offers all of the benefits of a modern building system with all of the familiarity and peace of mind that brick and block masonry construction brings. There are, however, distinct advantages over conventional masonry construction. So the first is the faster and easier laying of blocks. So with a typical mortar setting time of 20 minutes, once a course of blocks is laid, the next course can be started, thus enabling continual laying. Also, unlike normal tenon and mortar joints, there is little chance of the blocks floating on the mortar and the core setting down out of crew. Next is faster weatherproofing. Because of the quick and stronger setting of the mortar, continual laying is possible and weatherproofing can occur up to 3 times faster than with conventional methods, allowing follow-on work to commence inside of the building much sooner. Then less waste and mess. The mortar is a bag powder to which water is added, therefore only mix as much as required. No cement mixers are required, and no separate blocks of sand, cement, lime, admixtures, and so on. Airtight blocks can be cut, shaped, and so any damaged blocks can be reused. Flexibility. Only as much mortar to be mixed as required. Blocks can be easily ordered without lengthy lead times, and paying upfront as is typical for frame building components. Semi-skilled laborers can quickly learn how to glue the blocks together. Easy to adapt and overcome overlooked design flaws during the build quickly and expensively. So thermal mass, a heavy masonry building acts as a heat store, reducing the seasonal temperature fluctuations experienced in lighter weight construction. This reduces the need for secondary heating and cooling equipment, which has shown to significantly reduce the CO2 emissions of a dwelling over the nominal 60-year lifespan. Then the quality of build. The dimensional accuracy of airtight blocks means a more solid and tight-wall construction, and because the inner leaf can be built independently of the outer leaf, there is no chance for mortar snuts forming on the wall ties and in the cavity. Next is stability and strength. The fast setting and adhesive nature of thin joint mortar bonds the blocks together quickly and thoroughly, allowing builds to proceed upward quickly and safely. Furthermore, Eurocode 6 allows that thin joint mortar walls have an enhanced compressive strength over conventional mortar. Then enhanced thermal insulation. Thinner mortar joints means significantly less thermal bridging throughout the wall. U-value improvements up to 10% can be achieved over conventional mortar walls made with the same block. This could reduce the thickness of expensive secondary insulation in the wall, whilst still achieving the required U-value. Then increased air tightness. As with the improvements in thermal insulation, the significant reduction in the proportion of mortar in a wall improves air tightness of the construction. Furthermore, the likelihood of mortar beds and perpends being left unfilled is greatly reduced due to the laying technique and tools which practically assure a fully filled mortar joint at all times. Next is acoustic insulation. The cellular nature of aerated blocks provides a very effective barrier to airborne sound transmission. Thin joint separating walls can be built to Part E building regulations or robust details which have a proven successful track record. Okay, so this is their product, air tech blocks, and they use thin joint construction. Okay, so I'm going to post this also class in our Facebook group. Okay, then before that, I'm going to show you a video about thin joint construction.
We're going to show you the basics of building a pair of semi-detached houses using a thin-jointed aircrete frame. With the topsoil removed and We're going to show you the basics of building a pair of semi-detached houses using a thin-jointed aircrete frame. With the topsoil removed and concrete footings placed, lay H+H foundation blocks to the external brickwork level. Traditional sand and cement mortar is used to bring the inner leaf of Selcon jumbo blocks to the level of the floor beams. Vents are included at this stage and external brickwork brought to DPC level. With the ground floor installed using concrete beams and Selcon blocks and the DPC in position, construction of the inner leaves and separating walls can commence. The first course of blocks is laid on a levelling course of traditional mortar. It is important to ensure this course is perfectly level and vertical. Working from inside the houses and using the scoop to apply the self-fixed mortar, lay 8 courses of blocks. The separating wall is constructed using thin joint compatible party wall ties. These are used after the first row of jumbo blocks, then at alternate courses. Retrofit hangers are fitted to support the timber floor joists. Using an Arbortech or mortar rake, cut slots 80mm deep to receive the hanger towels. Self-fix mortar is gunned into the slots to secure the retrofit hangers in place. With the floor fitted, the thin joint blockwork can continue up to plate level. Timber plates are fitted, on top of which the roof can be built. We're now ready to add the roof trusses, which may also be attic roof trusses. Of course, the 300mm blockwork is used for the centre of the houses, on top of which the solid wood spandrel sits on the separating wall, in accordance with building regulations for sound control. We've shown spandrels for gable ends, but these can be built in blockwork. Felt is used to cover the roof, with wooden battens to secure and waterproof the house. The addition of windows and doors means our house is now weatherproof and first fix trades can begin. There are various options for insulating a thin joint house. Here we are using partial fill insulation, simply fixed with nylon insulation anchors. The exterior brickwork is tied with stainless steel helical ties to the blockwork. The ties are then mortared in as the bricks are laid. With our roof complete, all that's left to do is add the finishing touches to the house.
Okay, so thin joint aircrete is lighter, stronger, and faster. It offers continuous laying to story height, has excellent air tightness, reduces thermal bridging, takes the outer leaf off the critical path, and allows first fix trades early access. Okay, so class, this is our lecture, a short lecture for this week. If you have any further questions or clarifications, you can send a PM or send an email to my email ad. So stay safe and see you next meeting.